In this video, we're going to look at how to write out expressions for composite functions. So in the previous video, we worked out what fg of 3 was. And we saw that you input the 3 into the g to get 9 plus 5, which was 14. And then we input that 14 into the function f to get 2 times 14, which was 28. Now, that was helpful if we wanted to know what this composite function fg was for the input of 3. But what if we wanted to know what it is in general? What does this composite function do to x? How does it turn any input into its output? That's what we're looking at in this lesson. Right, let's look at this example. We know from the previous video that fg of x is actually f of g of x. So the input into my function f is actually g of x. Now, I've written this whole thing in red because the whole function g of x is actually going to be what I input into the function f. And you'll see why that helps in a moment. F of what? Well, g of x altogether is actually 3x plus 5. So 3x plus 5 is what I input into the function f. All I've done is substitute g of x for its expression, 3x plus 5. The key skill in these functions questions is substitution. Right, what's the next step? We're going to do f of 3x plus 5. So the input this time is 3x plus 5. And we know what f does to an input. Whatever the input is, you just do 2 times that input. So we're going to get 2 times this input. So what I've done here is I've looked at f of x and seen that whatever the input is, we do 2 times that input. Here, we happen to have f of 3x plus 5. We just do 2 times that input. And in this case, we can multiply this out to get 6x plus 10. So fg of x is 6x plus 10. In part B, we want to work out gf of x. So that would be g of f of x. And I'm going to use the whole of f of x as my input into g. So first I want to substitute the expression for f of x into here. So that would simply be g of 2x. We know that f of x is 2x. Now we're going to substitute 2x into here. The input now is 2x instead of x. So g of 2x is simply going to be 3 lots of 2x plus 5. Remember, we can think of this as g of the input is 3 times the input plus 5. So we're just going to do 3 times this input plus 5. And that will simplify to 6x plus 5. Notice this is not the same answer that we got for fg of x in part A. In that question we got 6x plus 10. So just like we saw in the earlier video, fg is not the same as gf. Here's part C. Pause the video and have a go at this one for yourself. Here's the answer. What I've done here is realise that hg of x is h of g of x. We don't have a single input x, so what we're going to do is use the whole of g of x as the input into h. G of x is 3x plus 5, so I've just substituted 3x plus 5 in. Now, h of 3x plus 5, remember, is just going to be that input squared, take away 1. H of any input is that input squared minus 1. So we're going to do 3x plus 5 all squared minus 1. Now to go from here to here, you need to be comfortable multiplying out brackets like this. Remember, this just means 3x plus 5 times 3x plus 5. If you expand and simplify, you end up getting 9x squared plus 30x plus 25 minus the 1, which is why we end up with a plus 24 on the end. Here's question D. Pause the video and have a go at this one. Here's the answer. G of x is simply g of g of x. So we're going to input the whole of g of x into the function g. So that gives us g of 3x plus 5. Now, g of this input is just going to be 3 lots of this input plus 5. So we're going to get 3 lots of 3x plus 5 plus 5. And if we multiply this out, we're going to get 9x plus 15, and then we have the 5 to add on at the end, so that simplifies to 9x plus 20. So g of x is 9x plus 20. This composite function can be thought of as 9x plus 20. We can just check that this works for an input, by the way. If we considered g of 1, we could do that the old way, where we input 1 into the function, and 3 times 1 would be 3, plus 5, that would give us 8. And then we would input 8 into this function g, the one furthest out. Inputting 8 would give us 3 times 8, which is 24, plus 5, which would give us 29. So doing it the old way, we could work out that g of 1 is 29. We can check that this works now using this function, this composite function. g of 1 would simply be 9 lots of 1 plus 20. And 9 lots of 1 is 9, plus 20 gives us 29. So this expression, once we've got it, is a faster way of working out the output for a given input than doing it in 2 steps.